Hello, how are you? Welcome to this video episode number 2 of solution of wave equation. So in our video we will show how to solve this equation and show that it is a solution of the wave equation. In addition, we will also work out the direction, the question, in which direction does it travel. We'll also show it and also give out clarity on physical wave, whether it's a physical wave or not a physical wave. Therefore, to start with, let us write down the wave equation itself. How does the wave equation look like? This is how the wave equation actually looks like. The second partial differential equation is just written like this, as simple as this: y squared, this is the second, now equal to 1 over v squared, and then we have psi all over partial with respect to t this time round. So we differentiate the function. Left hand side we show the second partial differential equation, differentiation value of psi with respect to y, and to our right hand side we have to show the partial differential of psi with respect to t, and thereafter we will be able to substitute and then solve the value of v. V is the speed of the wave. We also need to identify the speed at which the velocity is actually traveling. This is very important. It's very crucial in this particular video. We'll show it, so just keep keen, keep an eye, follow up, be careful with what we are doing. In case of any question, you can just write in the comment for further clarification. So we will use chain rule to solve this equation. Now the chain rule is very simple, but this is not the right time to show the sine rule. We already need to identify these values previously, that the first derivative, partial derivative of the psi with respect to y is given as cos y plus, it's not writing properly, but it's not a big issue again, plus 3t, close it, and then the second partial derivative of psi, sorry for this one again, with respect to y is given by negative sine. If you differentiate sine, if you differentiate cos, you'll get a negative sine. So you plug in the value 3t. Okay, close the bracket. Is very essential. It's very essential in this case. Thank you very much. So this is the first step that we needed. Therefore we go to the second part. This one will be to the left hand side, so bear in mind this one must be put in the left hand side. Okay, must be plugged in to our left hand side. Now we proceed further to differentiate partially with respect to y, t this time round with respect. So if we differentiate with respect to t, if you differentiate a sine, you will always get a cosine, but the 3t now, according to chain rule, it will come outside and become minus, not minus but positive 3. Okay, so we have this one here, minus 3, but now sine changes to cos, then y plus 3t, close the bracket. If you differentiate the same wave, but this time round with it's a second time differential, but now in that case you have to again use the chain rule. In this regard, you'll get negative 9, but if you differentiate sine, you'll get a cos, a negative. If you differentiate a sine, you'll get a what? A cos, but if you differentiate a cos, you get a negative sine. That is the difference now. So here we have 9, negative 9 sine y plus 3t. So this now will be to our right hand side. Let's go and substitute. Substitution starts with this one. Partial y, or with respect to y squared, equal to 1 over v squared partial psi with respect to t, the second derivative. We substitute this one right hand side and the one value we got from our left hand side, which was negative sine y plus 3t equal to 1 over v squared. Then here we plug in our value as negative 9 sine y plus 3t. Close it. Okay, now in this case the sine and sine must die because they are common, therefore they cannot lead to any other value except they are cancelling out. So we cancel these values, therefore we remain with negative sine, not negative sine, but we remain with negative 1, with negative 1 equal to 1 over v squared negative 9. Therefore our v squared is equal to 9. I think you know what is happening here. Negative and this negative, they will die as well. Therefore we just make v as the subject of the formula by finding the square root. Therefore we end up having exactly our v as plus 3. So according to the previous questions, we were supposed to answer whether it's a physical wave or not. In this case, this wave is a physical wave. It's a physical wave. It's a physical wave. If you can remember what we said about physical wave, it must be a sinusoidal wave. And in this case, it comprises of a sine. Therefore, it's a sine wave. It's a physical wave. The other part that we are supposed to answer is in which direction, because the function is y plus 3t. Therefore, it's traveling towards the negative y plus 3, towards this negative y plus 3. So it's traveling towards the negative y plus 3t. So it's a negative. That is the direction. Now, in line to this, you say it's traveling to the negative of y plus 3 with a velocity of 3 meters per second. This is very much important to put it there. It is not escapable. It is inevitable. In other words, inevitable. You have to mention that it's traveling at a speed of 3 meters per second to the negative of y plus 3t. Thank you very much for this short video.